So chapter 5 is a huge chapter on the biosocial development of 2-year-olds, or up to 2 years old. So we'll kind of go through quickly. There's lots of exhibits for you to look at, so I encourage you to pause if you want to and examine them. So what happens during the first 2 years is the growth in body size. The birth weight doubles between the month 4 and triples by 1 year. The average weight at birth is about 7.5 pounds, so you can tell where you were when you were born, or your children. Average length is about 20 inches. Some babies experience what's called birth catch-up, where they gain extra weight more than the norm would to catch up to their expected body size and weight. The norms, of course, are defined as a typical performance by which a child's development in a variety of domains can be measured. So when you have well baby checks, that's what they're basically doing. These numbers are norms of average measurements, and of course individual measurements may vary. They may vary over time. The percentile, the number of individuals, indicates the rank at which other similar people of similar ages fall in at. And the percentiles go from 0 to 100. You can see where body weight size and of boys and girls between birth and 24 months. You can see the slope is upward, with the 90th percentile being almost 50% higher than the lowest percentile. So the rate of increasing weight in the first weeks of life makes it obvious that new babies need to be fed both day and night. You can see the same boy, how much has changed in the first year of their life and by 24 months. What especially grows is the brain. 2-year-olds are totally dependent on adults, but they have already reached half their adult height and 3/4 of their adult brain size by the time they're 2 years old. Something called head sparing happens. It's a biological mechanism that protects the brain when malnutrition disrupts body growth. The brain is the least part of the body to be damaged by malnutrition, but in severe cases it is. There's connections in the brain. These are called neurons, the cells. You have about 100 billion of them in the nervous system, and they communicate within nervous system within neurons and between neurons. So at the base of the brain is the brainstem, working up to the midbrain, the cerebral cortex, and ultimately maybe the seat of consciousness, the prefrontal cortex. So what I would do is take the picture and I would stack it with brainstem on the bottom and prefrontal cortex on the top. You can examine the prefrontal cortex. One of the things you notice is that the wrinkling in the brain hasn't quite occurred yet. There is some, but it hasn't. It will take the next 4 or 5 years before it becomes more complex. Notice the frontal lobes, they're the largest lobes of the body. Cerebral cortex, of course, is the outer crust. Incidentally, it's about the thickness of 6 business cards, and if you unfolded it, it would take up about 3 square feet. Brain development continues with dendrite sprouting. So axons pull away from the neurons, dendrites actually extend toward other neurons, and the gap between them is called the synapse. From the synapse, from the presynaptic membrane, neurotransmitters are released that travel across the synaptic space to the postsynaptic membrane, allowing neurons to communicate with each other. This just shows what a typical brain cells look like. And you've got 100 billion of them with roughly 10,000 connections between one nerve cell and others. So the neurotransmitters go from the presynaptic to postsynaptic space. Neurotransmitters include things like dopamine, serotonin, norepinephrine, acetylcholine. Some are inhibitory, some are excitatory. They go from the presynaptic membrane. They're absorbed into the postsynaptic membrane where they cause action potentials and are recycled back to the presynaptic membrane. One of the things that happens, though, is this thing called exuberance. So specific brain structure and growth depend on genes and maturation, but even more on experience. So the more you stimulate the brain, the more it becomes exuberant, and the less you do it, the more it gets pruned. Expansion and pruning of dendrites occur for almost every aspect of early experience. Unused dendrites wither and allow space between neurons. So neurons that fire together wire together. Examples of what happens with brain experience come from twin studies. Until about 10 months of age, expectant circumstances are not influenced by socioeconomic status, that is, the type of income and home that you live in. After 10 months, genetics vary more than context in high socioeconomic status families. Examples from bird brains. Birds inherit genes that produce brain cells that need to be learned new bird songs and find hidden seeds. For dendrites and neurons to connect, birds depend on specific experiences with song learning and song finding. Infants need stimulation. Playing allows varied sensations and encouraging movements necessary for brain connections. Infant brains also need stress, but not an overabundance of it, because those stress hormones can later damage brain functioning. Infant need protection as well. Shaken baby syndrome is not that uncommon. It's a life-threatening injury that occurs when an infant is forcibly shaken back and forth. This motion ruptures blood vessels in the brain, and which leak out and break neural connections, especially the dendrites. So here's just an example of an interesting study. I would pay attention to this one on face recognition. The fusiform area of the brain is what allows newborn infants to recognize faces, but they need experience. So check it out. Newborn infants also need sleep. Sleep specific varies because of biology and the social environment. So newborns, believe it or not, need between 15 and 17 hours a day. Sometimes it's typically in 1 to 3 hour segments. Newborn sleep is primarily active sleep. They have a high proportion of rapid eye movements, whereas the eyes are darting back and forth, and the brain is setting itself up. Sometimes sleep problems occur. First-born infants typically receive more attention, and this may contribute to sleep problems. 1/4 of parents of children under age 3 report sleep problems. Parents' reaction to infants' sleep shapes the baby's sleep patterns, which in turn affects the parents. So it's kind of a vicious cycle. Some Asian and African mothers worry more about separation, so they sleep with their babies. European and North American mothers worry more about sex. So there are pros and cons to both of them. But one of the biggest cons, of course, is the higher incidence of sudden death syndrome. There's a video in the learning material about how to prevent sudden infant death. So check that out. You can also look at how often at night people wake up. Some disparities between Asian and non-Asian rates is because of co-sleeping. You see how much higher Asian co-parenting sleep and how their hours of sleep go down. This whole period of development is about perceiving and moving. It's about sensory development, having input to the sensation and perception parts of the brain, and how stimulation is super important. We'll talk about cognitive development in a couple of chapters, but suffice it to say that stimulation of the brain is very important. Perception follows sensation. As the brain's wiring up, the infant's able to perceive. And eventually repeat their own social experiences and identify their own perceptions that reoccur. Infant brain and auditory capacity to hear sounds in the usual speech range takes practice. The parts of the cerebral cortex, auditory and visual, dedicated to the senses, develop very rapidly. With auditory developing first, and visual developing last. Hearing develops during the last trimester of pregnancy. Most advanced in newborn senses. Some people believe that it actually wires up during gestation. Speech perception occurs by about 4 months after birth. Vision, the least mature of the senses, they generally focus between 4 and 30 inches away. There's also a video about this if you want to watch it. Experience and maturation of visual cortex improves shape recognition, visual scanning, and finding details. Binocular vision, that is being able to see depth perception, occurs at about 3 months. And of course, taste and smell are functional at birth. They rapidly adapt to the social world and relate to family and cultural practices. And believe it or not, they may actually have an evolutionary function, suggesting that infants don't eat foods that don't taste good. Touch is an important sense. It's very acute in infants. They like to cuddle. Although newborns respond to being securely held, sometimes they develop specific types of touches. Pain and temperature are also well developed. They connect up with touch. Some people assume that fetuses can't feel pain, but they can. Others say that sense of pain doesn't mature until a month or years later, but we can't know because we don't have first-hand reporting. And this just gives you some timelines of fine and gross motor control. It's worth checking out. Motor skills are divided into gross and fine motor. Gross motor skills include the ability to move around some parts of the body in actions ranging from large leaps to the flicker of an eyelid. Development always goes from the head to the feet, that's called cephalocaudal, and from the inner parts of the body to the fingertips, called proximal distal. Gross motor skills are physical abilities involving large body movements like walking and jumping and crawling. Dynamic systems underlie motor skills. They're super complicated. Just the mental capacity for an infant to stand up and walk is amazing. And it involves 3 underlying motor skills: muscle strength, brain maturation, especially certain parts of the cerebral cortex, and of course practice. The entire package of sensation and motor skills develops the ability to interact socially, the comfort on both the toddler and the parent, and of course involves some learning. Fine motor skills are the ability to move small movements, especially with hands and feet, and it might include drawing and picking up a coin. It's shaped by culture and opportunity. What's most important about kids in this age group is survival. At least 9 billion children were born between 1950 and 2010, with more than 2 billion of them dying before the age of 5. The world death rate of the first 5 years of life has dropped from 2% per year since 1990, and it's partly the result of clean water, better food, immunizations, and helpful medical treatments. This gives the rates of survival of infants. It's worth checking out. You notice the United States and Canada are far lower than countries like India, Chile, and Mexico. Diseases and early death are common in Africa, where this photo was taken, but neither is likely for 2-year-old Salem. So my first-hand experience in Africa was that sanitation, potable water, and places that infants and or parents cook food are all within a short walking distance and cross-contaminate each other. It's not uncommon for people to get diseases not only into their GI system, but through their skin, especially through their feet. So survival and success of survival depend on immunization. It primes the body's immune system to assist or resist particular diseases like mumps, measles, and rubella. It contributes to reduce mortality and population growth, and eventually causes herd immunity. So the inoculation of people for polio has basically led to all but small pockets around the world where it's eradicated, and that includes smallpox, measles, although there's mumps, I think, is making a return, and rotavirus. One wonders how long the coronavirus will be in the environment and how long it will take to come up with an immunization for that. Here's the example. Polio between 1985 and 2010 has all been eradicated. There were some spots in Africa where we were at, in Uganda, where we had to get a polio booster just in case. But I remember when the polio vaccine came out in the 1950s, I was one of the first groups of kids to get them. Case of polio worldwide jumps up and down, but in the United States it's pretty flat. Immunizations are unsafe, especially for people with compromised immune systems. Generally, the newborns get them on a fixed schedule from the pediatrician. There are some problems with some immunizations, particularly things like malaria, cholera, typhoid, shigellosis, and AIDS. So depending on where you go in the world, you may or may not have appropriate vaccines. So for Africa, it was required to have yellow fever. We had typhoid and cholera shots, but it's pretty significant just to be protected and safe. And in malaria, of course, there's no immunization for it, but there are ways to treat it or prevent it by taking certain types of antibiotics help. One big problem is adequate nutrition. For every infant disease, including SIDS, breastfeeding reduces the risk of, and malnutrition increases it, stunting growth of not only the body but the brain. Breastfed babies are less likely to develop allergies, asthma, obesity, and heart disease. Plus, they get the bonding from the mother. As the infant gets older, the composition of the breast milk adjusts to the baby's changing nutritional demands. So this just illustrates some of the benefits of breastfeeding. The U.S. tends in breastfeeding to be, you can see who is breastfed, how long they've done it. So the biggest majority of people have never been breastfed. So not only is it healthy for the baby, but it's practically inexpensive too. Stunting growth of children under 5 in different regions of the world. You can see where North America and Western Europe are, it's very low, whereas South Asia, Sub-Saharan Africa, where we were at, Middle East, and even East Asia are pretty high. There are different types of malnutrition, protein and calorie malnutrition, condition in which a person does not consume sufficient kinds of foods that result in several illnesses, severe weight loss, and eventually death. Sometimes there's stunting, where there's failure of children to grow up to normal height for their age due to severe and chronic malnutrition, and even wasting. A tendency for children to be severely underweight for their age as a result of malnutrition. One of the things in Africa that's interesting is not being able to actually tell how old somebody is because they're so small. Some children or some teenagers looked like they were actually late childhood, 10 or 11 years old, when they were actually 18. Two types of illnesses. There's a video you can watch about this too, where the brain does not develop normally, include marasmus and kwashiorkor. So it's worth a look at. One is a calorie deficiency and one is a protein deficiency. And typically the kwashiorkor happens after when mom's nursing a baby and gets pregnant again. There's not enough milk to go around. Sudden infant death syndrome is a common problem in Western cultures. The situation in which seemingly healthy infant usually develops 2 to 6 months old, suddenly stops breathing and dies unexpectedly while asleep. There have been some studies around the world that conclude that the factors that increase the risk include sleeping position, so back is best, maternal smoking, and the type of bedding that's used. But again, there's a video for you to watch if you like on this. And of course, once um, uh, practices are instituted to change this, the SIDS rates go down. The success in reducing SIDS underscores several themes described in this chapter. And so prevention rules the day. And that's the end of this presentation.